Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. And they also have a new object storage service to make storing data for your apps even easier. Go to pythonpodcast.com/linode, that's Linode today, to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, ODSC, and Data Council. Upcoming events include the Software Architecture Conference, the Strata Data Conference, and PyCon US. Go to pythonpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host as usual is Tobias Macy, and today I'm interviewing Ivan Kravets about PlatformIO, an open source ecosystem for IoT development, including a cross-platform IDE, unified debugger, remote unit testing, and firmware updates. So Ivan, can you start by introducing yourself?
Yes, so hey everybody. Tobias, thank you so much for hosting me at your podcast. My name is Ivan, and I am from Ukraine, and I'm the founder of the PlatformIO project, where currently I am responsible for different aspects of this project. It's the business side, architecture, marketing, and sometimes even technical support. I'm also a teacher in the past and spent around 10 years in the web development. It's the backend plus the front end, where I mainly use PHP language.
And do you remember how you first got introduced to Python?
Yes, it was 2012 year. No one introduced me to the Python. I actually moved to the new house, and I spent a lot of time for home automation, and I use different hardware in the home, and I had the problem to manage all these different devices because they use different network interfaces. And I looked actually for the network-driven asynchronous framework, and I found Twisted. And this is actually how I met first time the Python. It was the Twist engine.
And have you taken a look at all at Home Assistant, or were you involved in the home automation before that project was even started?
Yes, it was 2012 year. I don't remember having had Home Assistant in this time, but the whole thing which I did in the 2012, it was actually to create the bridge between the hardware and actually the Home Assistant. And the project was named like Smart Angel. I spent 2 years for this project, and this is actually the place where the PlatformIO was born. Because Smart Angel project, this is high-level abstraction on top on the hardware, and the Home Assistant can actually communicate with the Smart Angel using this API interface. And the PlatformIO was used here just to deploy special firmware, or we call this operating system, to the different devices, where end developer who will work with Smart Angel project will actually communicate with the network device. And it doesn't matter which type of network the end device will use. The Smart Angel emulate one type of connection and one type of interface.
And so were you dealing with things like Ethernet and Zigbee radios and 900 megahertz band and all these different types of interfaces that you're trying to abstract across?
Yes, you're right. So I even called Smart Angel like heterogeneous network. So where you can connect different devices, even devices without connectivity. I mean that you can connect your very simple constrained device through the serial interface. And actually, when you will work with the Smart Angel, you will work with the device which will look for you like a network. You can even ping this device. You will have special address of this device, but on the hardware layer, this is not a networking device.
So you had the dubious pleasure of being able to try and make RS-232 usable.
Yes, 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 yes.
And did you have much of a background in hardware engineering and dealing with these different embedded platforms prior to trying to build this home automation platform, or is this something that you just learned as you got involved with it?
Yes, this is really the funny, but I am not electronic engineer. So I created this. I founded PlatformIO, and I am not professional or professional embedded engineer. And I think this is the main or the key success of the PlatformIO, because I don't look on the PlatformIO from this hardware or embedded square. I don't have these limits. I look from the perspective where I can build amazing user experience for the developers. Because when I mentioned before that I say that I spent 10 years for web development. And when I worked with web tools, they look for me really cool, because you can press one button, you can do debugging. You can, for example, press to run script, you will receive the result. And if we talk about the hardware, about the embedded, this is a really complicated step. Even trying to do debugging, you need to know a lot of different complex things. Not saying how to configure them, but you actually need to understand how these things work. And I actually, with the PlatformIO, learned a lot of things and went to the embedded together with the PlatformIO.
And so, can you give a bit of a description about what PlatformIO is now and some of the different features that it has and how it helps to simplify the work of interacting with and developing for these different embedded platforms?
Yes, as I already mentioned before, the problem is to flash or to program this device. The PlatformIO is the open source tool, and sometimes I even call it like the Swiss knife, because with the PlatformIO, you could be focused on the code writing, and you can actually just explain PlatformIO what is the type of your hardware. And the same when you press run button in your IDE to run Python script, the same you do with the PlatformIO. You press like, hey platform, please flash these three boards. And before this, you will just explain PlatformIO. I have the board A, it's based on the architecture ARM, for example. I have the board B, it's based on the architecture RISC-V. Or I have three boards and sort of them is based on the AVR. And you ask PlatformIO, please build my project in Flash, all these boards. And PlatformIO now resolve all this complexity automatically for you. So it knows which toolchain to use, because you know that for these three different architectures, you actually need to use three different toolchains. And if we talk about different frameworks or SDK, you also need to know how to link your software, your project with these frameworks. You need to write some build scripts or similar to that. But with PlatformIO, you don't need to do this, because before adding new hardware or new development kit to the PlatformIO, we already provide full detailed information about this device, and we know how to do building, how to do uploading, how to do debugging, or how to do unit testing, or how to do code static analyzing, and different aspects. Mainly when people work with the PlatformIO, they even don't know which toolchain do we use or how do we compile code. And I think this is the best what we could achieve with the PlatformIO, because now developers, companies, they could be focused on the code writing and on the getting result in a days, not in a weeks. So no need to spend just 1 week to learn how to program this board, read long list data sheets. No need to do this.
And so you mentioned that the original inspiration for building PlatformIO was just trying to solve your own problem of getting all these different devices in your home to be able to talk to each other. And so what was your motivation for deciding to continue working on it and developing it as a product and then building a business around it?
Yes, so the main motivation was just to save my time, because Platform.io wasn't created like the project, like the business project. It was the hobby project. And if this is the hobby project, I had a limited time to work on my hobby projects, like the Smart Angel, which I mentioned before. And you know that the main motivation was to save my time. So I don't want to spend yet another week to learning how to program yet another hardware. I remember that night, it was 2012 year, I had three different boards on my table, and I used three different ideas. So one idea to program Arduino board. The second I use ARM embed. Today is ARM embed, but before it was embed project. I use their online IDE to program this board. And the third, I have Texas Instruments Code Composer Studio to program their launchpad device. So, and actually the problem, every time when I back to my hobby project, I should spend 10, 20 or 30 minutes just to remember what I did before. Every time I lost the time, and this was the time on remember the context of the previous steps on which I stopped. So, and the main motivation for the PlatformIO was to support hybrid configuration, where I can easily add new hardware, and no matter on the which type of architecture this hardware will be built, or on the which type of framework my project will be built. So the goal was to have one universal instrument or tool which will do this work automatically for me.
And one of the interesting things that has been a recurring theme in talking to people who start a project as a reason for facilitating a particular hobby is that they never actually end up completing the initial reason that they were starting on this other side project. So, for instance, I know that Glyph, who created Twisted, built it because he wanted to have it as a component for building a video game, which he never completed. So I'm wondering if you ever actually ended up finishing your home automation project, or if you got too sidetracked into PlatformIO and now you've got some half implemented home automation platform.
Actually, I stopped work on the Smart on Hill project, and I focused just on the PlatformIO, because PlatformIO was really small puzzle in the Smart on Hill, and I thought that PlatformIO is very easy project, but it's really complex. It's already had took it's 6 year for us, and a lot of work. But why I am super happy that the PlatformIO wasn't started as a business project, and it means that we were not focused on the money. I mean that we had a time to talk with the customers, we talked with the user. I spent a lot of time going to the end user machines, where I wanted to learn how users work now, which tools do they use, why they decided to try PlatformIO, which features are missed in the PlatformIO. I mean that this first 2 or 3 years they were great for the PlatformIO, because we could get this market adoption. We finally realized which problems we resolve, and now is yet another how to correct say is another level within the PlatformIO, where we are going to the enterprise market. And this experience which we got from the makers world, we are super happy to repeat with this enterprise market, because we need to do the same. You know that in the enterprise market there are also yet another tools, and these tools are different. Most of them are closed source, most of them are paid, and actually for the enterprise companies there is no problem to pay for these tools. And even if our tools are cool or free, it's very difficult to convince some managers to use PlatformIO. And again, you need to learn, need to understand what is missing in the PlatformIO. I mean, a lot of work again for us now.
And what are some of the aspects of embedded development that keep you interested and engaged in this space of the developing for these different types of hardware? And what are some of the types of projects that somebody might use PlatformIO to be able to build?
To be honest, I don't do a lot of embedded programming today. As I mentioned before, I moved from the web world, and in this world, developers are mostly focused on the code writing or the code writing. As I mentioned before, they don't want to spend these hours to get the result. Embedded world is really complex, and every day for me just to improve the user experience, to simplify these complex things which I mentioned before, like toolchains management, build scripts, moving between different host machines. It's really the crazy problem. And the last really big problem that the companies which work on the hardware project, there is the problem for them to find a really skilled embedded engineer. And the goal of the PlatformIO is to allow these companies to hire just high-level professional C++ developers and no need from them to be skilled electronic engineers. I mean that if we have some generic team, no need to have 100% of super skilled electronic engineers. With the PlatformIO, we can have 1 or 2 engineers, for example, and 8 or 10 just super talented C++ developers who can read API of the operating system, or who can do classic things which they did before the embedded world, whereas they would like to be focused just on the code writing. They just want to press some button to do debugging or unit testing, and they don't have time and don't want to learn all these complex things from the embedded sides.
And in the time since you first began working on PlatformIO, I know that there's been a lot of renewed interest in embedded systems development and hardware hacking, and there have been different projects that have tried to bring higher level languages to those platforms for at least hobbyist projects. And I'm wondering how the overall evolution of the space has impacted the direction that you're going with PlatformIO and some of the focus that you've put into it as far as what problems you're trying to solve.
I think that the most important thing which happened for the last years is that finally semiconductor companies have started looking onto the open source community. So you see a lot of news where different companies open source their real-time operating system. This is the first. The second, if you take a look at the embedded market, most of IDEs are based on the Eclipse. And today, these chip vendors, they finally realized that the new generation developers, they would like to have something much better than the Eclipse, which has a lot of different features capable for installing new plugins, easy for extending, and there are a lot of internet things which change for the 6 years. And the third things which is very important for the last years, this is the Arduino ecosystem, because you know that before 2017, most of us looked on the Arduino like on the neutral and open source ecosystem. But you know that after that time when ARM acquired Arduino, we have the problem with the Arduino today, because all of their new hardware, they are mainly based on the ARM, and all of their new tools, they are fully source closed, and even paid. So, and this is a really big problem for us, because we spent first 3 years, we like so much Arduino, and we spent 3 years for the Arduino just to try to improve this ecosystem, to provide more advanced tools for developers who need more advanced instruments. And now we are actually in the stage where we are looking to add more different frameworks to our ecosystem. So today we have support for around 20 different frameworks and SDK, and Arduino, this is just the small puzzle in our ecosystem today.
So, for engineers who are building software for these different embedded platforms, what are some of the common challenges that they might encounter, and how does the complexity of dealing with multiple different hardware targets influence the way that they might design and implement their software?
So, the problem is actually starting from the semiconductor vendor. So when you start your project with some hardware, the chip vendor locks you just to this hardware. Because if you go to the website of this chip vendor, you will see that this vendor recommends using their special tool or ID. And for you, it's very the big problem if you decide to move from this vendor's ecosystem to something new. For example, if tomorrow there is new MCU, which is much better in comparison with the MCU which you use today, you will have a lot of problem if you want to switch to this competitive MCU, because it's the different SDK or different framework. you need to install yet another IDE. You need to learn how to work with that. And this is actually the big problem. And the PlatformIO is fully agnostic to the architecture of the MCU. And our customers no need to worry which hardware or which board they use, because for them it looks like a change in just a one line in the configuration file. So let's imagine the same. If tomorrow we have the better MCU or the better hardware, our customer will just change this line, like my new development kit is something new, PlatformIO please build. And you don't need to do any change in your project. You can use your favorite IDE. You can use your favorite operating system. You don't need to move, for example, to the Windows if a chip vendor supports only Windows. You can use any operating system, any IDE. You actually have full freedom. You personally decide how your development environment will look for you. And what is very interesting is that the only PlatformIO allow developers to use different operating system and work on the same project. So let's imagine that someone preferred to use Mac OS and Eclipse. The second preferred to use Windows and Visual Studio Code, and the third engineer preferred to use command line and Vim. All of them work on the same project. The configuration is located in the one file called platformio.ini. No other configuration. Without the PlatformIO, for example, if you use classic tools which we have today in the embedded market, the whole configuration is located directly in the IDE. So if you do one change in this IDE, you need to ask your colleague to repeat the same. Like you add new build flags or you do some change to the debugging, you need to explain other colleague to repeat this step. I even don't say how many problems you will have if you try to move this project to another host machine, Linux or car-sized PC. With the PlatformIO knows this problem, because as I mentioned before, all these problems were resolved with the Smart Angel, because these problems were for the Smart Angel like a number top of one. Because within the Smart Angel, we just explain what is our hardware, and it doesn't matter which operating system you will use, even car-sized PC.
And so, for somebody who is using PlatformIO for being able to work on one of these projects, can you talk through the overall workflow of getting started and setting it up and specifying what types of libraries you need and the different hardware platforms that you're targeting?
So it's very easy to get started with embedded, because you can go to the platformio.org website. We recommend to get started from the Visual Studio Code extension. We have official PlatformIO extension for the Visual Studio Code. You'll just download Visual Studio Code, go to the extension section, search for PlatformIO IDE, press install button, and finish. You will see PlatformIO Home, a really nice interface, which will ask you about your hardware. You select your hardware, select your framework, it could be Arduino, and you can start writing simple project like Blink or Hello, similar to Hello World, and board flashed. No need to install any toolchains manually. No need to learn how to write a build script. Nothing. Just need to be focused on the source code writing and read some guides how to do embedded development. So it's very easy with the PlatformIO.
So, can you talk through a bit about how the PlatformIO ecosystem is actually implemented and some of the different components that comprise it, and just how some of the overall system design has evolved since you first began working on it?
Yes, it's really good question. So if we talk about the smart Angel, so the number one reason why Python was used is the twisted. And if we talk about the PlatformIO, this is again there is number one package or library which we love so much. And this is sconce or sconce. I don't know what is the correct pronunciation. So the sconce is super cool. It's amazing. So it could be used like a build system. So you can use it like the replacement for make or CMake build system. But the magic side of the sconce is that you can use it like a library. So the sconce is the heart of the PlatformIO. The whole things which we have is the build workflow with the PlatformIO. We do it on the top of the sconce. So we extended the sconce with our interfaces. We created this unified interface for multiple different development platforms, and now this separated development platform, we call it, like for AVR or for ARM or for other architecture, just communicate with the PlatformIO core API and explain, hey PlatformIO, I have this source code. I would like to use these flags to build C++ type files, these flags for our assembly files. I would like to do a linking process or something in this way. The upload process should look in this way. And we call this thing like decentralized architecture. It means that if we take a look at the PlatformIO core, there is nothing common with any architecture. It's fully agnostic to any architecture, and you can easily integrate any hardware and any architecture to the PlatformIO. No need to do any contribution to the PlatformIO core from this side. It's very easy to create your own development platform for your hardware and just reuse whole power of the PlatformIO. And the main benefits is that using this very simple interface, you will just explain within your development platform how to do building, debugging, and other things. And your hardware is automatically integrated into our 10 different IDEs. The Eclipse, Visual Studio Code, Qt, C-Line, a lot of them. Because you don't need to spend again your time to create extension for these IDEs. We already did this. If your hardware is integrated to the PlatformIO, your customers automatically receive this huge list of IDEs. Your customer can use any operating system, Mac, Linux, Windows, FreeBSD, even car-sized PC. Your customers can test their project with different continuous integration services. They can use different static tools for static analysis. They can easily do debugging even if they don't know how to do it, because they will just select the type of debugging probe, press the debugging button, and they will be the main function.
And you mentioned that scones is the sort of core reason that Platform.io is built around Python. But if you were to start the entire project over today, are there any things that you would do differently in terms of the overall design or project focus or the implementation language?
I think everything was done correct, and if we even back to the PlatformIO core history, we haven't had any change since 2016. So the architecture which were implemented in 2016 were not changed today. The only one things which we maybe would like to change is the mistakes that we were focused on the Arduino. And today, if you try to talk with someone and you will ask, have you heard about the PlatformIO? Most of people will say, yes, we know this is like replacement for the Arduino and amazing tool for the makers. And this is actually the problem for us, because most of people look on the PlatformIO like for the replacement for the Arduino or for the tool for the makers. And it makes the problem for us if we try to move to the enterprise market and to have support for this low-level frameworks, hardware abstraction library, and SDKs. Because most people think that platform is just only for the makers world, but that is not true. So I think this is the only one things which, or thing to miss a mistake. I don't know. It could be really great if we from the first year already started support different frameworks, not only Arduino.
And so, beyond the development of the software for these different platforms, there's also the concern of verifying that what you're building is actually going to work. So, things like unit testing, and you mentioned debugging. And I'm wondering, what are some of the challenges in the embedded software space for being able to handle those aspects of the software development lifecycle, and some of the ways that Platform IO helps in that effort?
Yes, so if you do debugging, for example, if you do debugging of Python application, this is not a so complex technical task, because you do this work on the host machine. But if we talk about the hardware, debugging, unit testing, we should do on the hardware. And you know that hardware is very constrained, it's very limited. If we say about the host machine, this is gigabytes of RAM. And if we talk about embedded device, this is kilobytes of RAM. and also sometimes in kilobytes of flash. And you can't upload some complex testing framework to this device, and you can't do some crazy complex debugging on this device. And in this case, if you try to do this manually, it's a little bit difficult because you need to create some bridge interface to communicate with this device. But with PlatformIO, it's very easy because we have some abstraction based on top of Unity framework. It's the C++ framework, and you can actually use the same workflow which you use for the Python. You can write your unit tests. They look very similar to the Python unit testing workflow. And the same, you will just press test button, and PlatformIO will compile your source code, deploy to the end device, gather results, analyze result, and just present you some feedback with results on your host machine. You can even do this using PlatformIO remote service. So it means that you can work with your hardware or deploy tests to a remote device which is not actually connected to your machine. Let's imagine that you have some device, for example, a Raspberry Pi or similar to that. You connect some embedded devices through the cable or through the Wi-Fi, and you can work with these devices from anywhere in the world, and you can deploy this unit tests or similar to that, or flashes board or over-the-air updates, and no need to be connected directly to this device. And the big benefits of the PlatformIO remote that you don't need to open any SSH or other ports to your remote machine. There is PlatformIO broker which resolve these problems automatically for both ends.
And one of the other complexities with deployment, particularly in these embedded systems, is what happens when something goes wrong. And so being able to prevent that from being the case, or for cases where maybe you're trying to deliver remotely over the network, where there might be some issues with corruption of the data in transit, or where the network might drop out before the flashing operation is completed. And so I'm wondering, what are some of the guards that you have in place, or some best practices for people who are working in the space to prevent that type of problem from happening?
So there are actually like two types of thermal flashing, which you mentioned. So the first, you can flash your device using hardware interface through the USB cable, or the second option is to deploy firmware through the air, like over the air updates. So all these operations, they are fully different, because in the case with the USB, it depends on the upload protocol and upload tool. Most of them have built-in different uh, mechanism mechanisms which verify deployed firmware on the target device before flashing. But in case with over-the-air updates, the end developers should personally implement these things on the end device. So the flash, which is on the device, it should be split it is minimum into two parts. So one bank is for example, for the working firmware, and the second bank for the update, which is coming through the over the air channel. And if you, for example, if the firmware has not been downloaded correctly, you will not change some special flag within your bootloader that new firmware is ready. It means that if you deployed 70% of your firmware, for the end devices it's not 100%, and this firmware will not be accepted. I mean, it's not a problem. I mean, this is the responsibility of the developer who will implement this. Different embedded devices requires different approach how to do this.
And in the PlatformIO remote, do you also have a facility for being able to track inventory of the different devices that you have out in the field and the version of the firmware that they're running, so that you can see what you have and what still needs to be updated, and maybe be able to handle some of those failed deployments by seeing that, oh, this still hasn't been updated, I need to retry the delivery?
So PlatformIO remote actually emulates everything what you do in your host machine. So if if you can, let's imagine that this device is connected to your machine. If you can check from your device the version or different things, you can do this the same with the PlatformIO remote. So this is not like device management system. This is actually the tool which allow you to do the same what you do on your desktop machine. So if you can flash your device, or you can connect to the serial port to the end device which is connected to your machine, you can do the same operation with the device which is connected to the remote machine. If you provide some information from the serial interface which will return some information about the firmware version, you will receive the same if you try to connect this device from the platform remote.
And so, in terms of the projects that you've seen people build using PlatformIO, what have been some of the most interesting or unexpected or innovative uses of the platform?
So there are a lot of interesting projects built not on top of this using PlatformIO. I think the most interesting of them, this is ESP I don't know what's the correct name, because a lot of interesting projects are built on top of the Espresso board. And there is the Espresso company, and it has very interesting MCU which has on board Wi-Fi. Also, there is very interesting project called Marlin. So they created a universal firmware for different 3D printers. It means that anyone can download their firmware, select the type of the main controller in the printer, and tune this printer, tune configuration. And there is also ESP Home project. It's very interesting library because it could be used in pair with the Home Assistants. So you install the Home Assistant, you will use this ESP Home library, flash your device, and you can easily manage your home embedded devices with Home Assistants.
And in terms of your own experience of building PlatformIO and working in this embedded hardware space, what have been some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think that the most interesting things when we try to add support for some new SDK or operating system. The last time I remember we added support for Zephyr real-time operating system, and it was really a really interesting case for us because Zephyr is based on CMake generator tool, and we finally decided to not use static code building. It means not to provide static flags for building the source code, and we actually communicate with CMake generator tool, and we can provide the same build workflow which you will receive if you will use Make or other build tool. So it's really interesting because the final project is compatible with the PlatformIO, and also you can use it with the standalone CMake tool.
And in terms of sustainability of the PlatformIO project and the business that you've built around it, what is the overall business model and how are you approaching things like project governance so that people aren't driven away by the perception of PlatformIO kind of governing the entire process and not really taking community feedback and just the overall community and ecosystem that you've been able to build up around it?
Oh, it's really good question. So we actually had the problem with this because, as I mentioned before, the PlatformIO was a hobby project for me, and I didn't think that it will be so much popular. And when I started work full time on the PlatformIO, it was 2016 year. I hoped that chip vendors companies they will be interested in things what we do because our tools are open source, they are free, developers are super happy, but it was really a wrong way. And I remember the time I even created the post in our community forums and actually asked people what to do next because it was the time where I thought what to do is the platform, go to full-time work and again back platform, like the hobby project, or continue to work on that. And in 2017, we added a few interesting features to the platform and made them paid. So a lot of people supported us, and actually we are super thankful to them because they help us to survive. And the previous year, 2019 years, was really cool for the PlatformIO. We finally made again PlatformIO fully open source and fully free, thanks to the Western digital company and the sci-fi. So they help us to make all the things free, even the PlatformIO remote. And the second part of our business model, we provide consulting to companies which use PlatformIO for their project. And also there is new direction in our business. We work so close with semiconductor companies and help them to save a lot of not only financial resources but also the time resources. Because if you chip vendor and you would like to introduce into the market yet another chip, you will need to spend a lot of resources to create yet another idea and to provide the interface how to work with this hardware. Normally it will take you 6 months or even a year, but with the PlatformIO it can take you days, not even weeks or months. The previous week, I posted in our social network a really interesting use case where a Chinese company integrated their processors into the PlatformIO in 2 days. So 2 days, and they receive full featured, really professional idea, and they not only save time and resources, they already have a working solution for their customers. So they can personally decide which idea to use, which operating system to use, and this is really the great use case.
And what do you have planned for the future of the PlatformIO project?
So I don't look on the PlatformIO like on the project for the 1 year or two. For me, PlatformIO this is the project for the years, and my final goal is to see PlatformIO everywhere. This is similar to the Linux, where today Linux the mainstream operating system. This is actually the same. So if we talk from the end developer perspective, there is the huge problem in this market embedded, because if you have 10 different hardware on your table, you will need to install 10 different IDs. Every time you need to switch between these IDs, not matter, even if this Eclipse, you need to have 10 different Eclipses with different plugins. And PlatformIO is unique solution for these problems, because we can have one ecosystem and one environment and one development tool for 1,000 different MCUs and development boards. This is actually the goal. It's not only win solution for the developers, but it's also the win-win solution for manufacturers. Because let's imagine if you are super talented in creating new hardware, you actually buy the MCU from a chip vendor, and you will be in the position where you will need to provide some interface to program your hardware. And you have a few options. Or you will try to invest in your own software and your own idea, or you will try to contact the chip vendor and ask, please add support of my custom hardware to your idea. And the last step, it doesn't work. So in the platform is actually a win-win solution for developers, for manufacturers, and for chip vendors too, because all of them will be focused on the one software tool for these hardware products.
Are there any other aspects of the work that you've done on PlatformIO, or your experience of working in the embedded hardware ecosystem, or any of your overall experience in general of building and maintaining an open source project that we didn't discuss that you'd like to cover before we close out the show?
No, I think everything is covered.
All right. Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose a brief article that I read recently about some research being done at the University of Massachusetts Amherst about being able to harness electricity just from the humidity in the air by using these protein nanowires connected up to an electrode. So some pretty remarkable work being done. And pretty exciting to think about some of the different ways that it can be applied. So I'll add a link to that in the show notes. And with that, I'll pass it to you, Ivan. Do you have any picks this week?
Yeah, so I actually would like to share my short experience with the PlatformIO. So I think that the one really great advice from my side is to not to be strictly focused on the money side of your project if you started to work on that, because business this is not about the money. This is about the processes, about the management of the processes, and the money is actually the mark of your results. And if you try to work on your own project, I would really recommend to contact with everyone customer. Go to their machine using remote tools. Learn more which competitive tools do they use. Ask about why do they use. Don't think that you will waste this time. This time is very valuable.
All right. Well, thank you very much for taking the time today to join me and discuss your experience of building and maintaining and using the PlatformIO project and working in this embedded hardware ecosystem. It's definitely an interesting and challenging space, and I'm glad to see that there are people like you who are out there trying to make it simpler. So thank you for all of your efforts on that front, and I hope you enjoy the rest of your day.
Thank you so much too for your time and for the invitation. Thank you.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.